Good morning, class. Welcome back with me, Miss Diah, in mathematics class. On this occasion, I will explain about one material that very famous. Are you curious? If you're curious, watch this video until it's finished. But before that, let me introduce myself. My name is Putu Diah Pratiwi. You can call me Diah. And my student ID number is 211301111. I'm from 4D Mathematics Education class. The golden sun above the horizon, a beautiful moon on a scary night, and many natural objects in this world have the same figure. Even man-made objects like cups, plates, rings, and many more are developed with the same figure. What common shape is being illustrated in these objects? Circles, right. Here we're gonna explore the real-world facts about circles. But before that, let's see what is the subtopics we will learn today. First, about the definition of a circle. Number 2, about the elements of a circle. Number 3 is about the circle area and circumference formula. And last is about solving circle case in daily life. Okay guys, first let's start talking about the definition of a circle. What exactly is a circle? Or how is the circle formed? A circle is a collection of points, but can randomly placed points form a circle? No, right? So, can you tell me how the points comes together to form a circle? That's right, a set of points on the same plane which are at an equal distance from a single point form a circle. Yes, a set of points on the same plane at an equal distance from one single point. This single point is called the center of the circle, and this distance between the center and all the points is called the radius of the circle. For you can more understand about the definition of the circle, let's see this GeoGebra. Look at the screen. For example, I have a circle with a radius of 5 and the central points of the circle equals point A. So we can call this circle is circle A. After that, I put a point B in a plane of the circle. So because that, I have a radius for the circle with segment AB. And if I move point B, you can see that the distance of segment AB is always the same. Look at this. If I move to point B, the distance or radius is always the same, yes? So that's the illustration about the definition of circle. Now, let's see something interesting. Mathematics has a lot of branches such as geometry, algebra, logic, number theory, etc. But for now, let's focus on geometry and algebra. Let's see how we can represent a circle in geometry as well as algebra. We all know that this is the geometrical representation of a circle. But do you know its algebra representation? So, the algebraic representation of any geometrical figure is called an equation. To find the algebraic representation of a circle, we need to find its equation. To find the equation of a circle, let's name a few things. Let the center be O and that its coordinates be h, k. Similarly, let P be any point on the circle with x, y as its coordinates. Also, let's denote the radius by r, so the distance between points O and P is the radius. But how do we find the distance between the points O and P? Since we know the coordinates of O and P, we can find the distance O and P using the distance formula. So we get this. Squaring both the sides, we get this. This is the general equation of the circle. Now that we have seen the general equation of a circle, can you tell me the equation of a circle whose center lies on the origin? Yes, you're right. Since the center is the origin, the values of h and k becomes 0. Substituting these values in this equation, we get this. And solving it further, we get this. This is the equation of a circle with the origin as its center. So now we know how to represent a circle in the geometry and algebra. Next, let's talk about the element of the circle. There are 8 circle elements that we will discuss. There are first, center point, next, radius, diameter, arc, chord, sector, segment, and apothegm. The first element is a center point. The center point is the first circle element that you need to know. The point directly in the center of the circle is called the center point. The distance from the center point to all points on this circle is always the same. The central point is often symbolized by using capital letters such as A, O, B, C, etc. The next element is the radius of the circle. The radius can be interpreted as the distance between the center point of the circle and the point on the circle. The radius of a circle is always the same because the distance between the center point and all points on the circle is same. In mathematics formula, the radius is often notated by the letter R. Element number 3 is diameter, the length of the straight line that connects any 2 points on the circumference of a circle and passes through the center of the circle is the diameter. It can be said that the diameter of the circle is twice the value of the radius. In mathematical formulas, diameter is often symbolized by the letter D. Moving on, another concept we need to know is that of chords in circles. They are line segments which have the endpoints lying on the boundary of the circle, like this one or this one. Both are called chords as the endpoints lie on the boundary of the circle. Let's go back to the diameter. The endpoints of the diameter also lie on the boundary of the circle, right? So, is this a chord too? Yes, it is, but it's a special one. It's the longest chord of the circle. The next circle element is the arc. What is meant by an arc as an element of the circle? The part of the circle in form of a curved line is the definition of an arc. There are 2 types of arc in a circle, namely major arc and minor arc. An arc whose measure in less than 180 degrees is called a minor arc. An arc whose measure in greater than 180 degrees is called a major arc. An arc whose measure equals 180 degrees is called a semicircle, since it divides the circles in 2. The next element is sector. The area is flanked by 2 radii, and a circular arc is the notion of the sector as a circle element. The sector on the circle is divided into 2 parts, namely the major sector and the minor sector. The smaller area is known as the minor sector, whereas the region having a greater area is known as major sector. Next is segment. The area enclosed by the chord and circular arc can be interpreted as a segment of the circle. The last element is an apothegm. The perpendicular line segment connecting the center point of the circle with the chord of the circle is defined as the apothegm. Another definition of apothegm is a line segment with one endpoint at the center of a circle and the other endpoint on the midpoint of a chord of the circle. Next, we will discuss about circle area and circumference formula. The first is about the circumference formula. To calculate the circumference of the circle, you need to know the radius or diameter of the circle. There are two formulas we can use to find the circumference. If the diameter is known in question, we use this formula, with K as the circumference and D as the diameter. On the other hand, if the radius is known in question, we use this formula, with R as the radius of the circle. Why is the formula like that? Since the length of the diameter is twice the length of the radius. Remember to know the value of P can be 22/7 or 3.14. We use P is equal to 22/7 if the radius or diameter of the circle is multiplies of 7. Besides that, use P as equal to 3.14. For you can more understand about circumference, let's see this example. A circle has a diameter of 28 cm. Find the circumference of the circle. From the question, we know that the diameter of the circle is 28. So, we can use the formula K equals P times D, with P equals 22/7. So, we can write K equals 22/7 times 28 cm. So, we can get K equals 22 times 4 cm. So, we can get K is 88 cm. So, we get the circumference is 88 cm. We can try to use the other formula and we get the same result. Next, we will discuss about circle area formula. For we can find the area of the circle, we can use two formula. If D is known, then the formula for the area of a circle is area equals 1/4 times P times D squared, with A is the area of the circle and D is the diameter of the circle. On the other hand, if R is known, then the formula for the area of a circle is area equals P times R squared, with A is the area of the circle and R is the radius of the circle. Same like before, the value of P can be 22/7 or 3.14 or can be 3.14. We use P is equal to 22/7 if the radius or diameter of the circle is multiplies of 7. Besides that, use P as equal to 3.14. Why is the formula of the circle area like that? To know about that, let's see this illustration. We can rearrange the circle B like this. If we divide the circle B 200 parts or more, we can see the circle can be a rectangle. And as we know, the area of rectangle is length times height. From this picture, we can see the length of the rectangle is PR and the height is R. So we get the area of that rectangle is PR square. And because the area of the circle equals area of rectangle, so we get the area of the circle is PR square too. Because that reason, we can get the formula of circle area is PR square or 1/4 times P times D square. For you can more understand about the area of the circle, let's see this example. If the radius of a circle is 7 cm, find the area of the circle. From the question, we know that the radius of a circle is 7 cm. So we can use the formula area equals P times R square with P equals 22/7. So we can write area equals 22/7 times 7 centimeters times 7 centimeters. So we get area equals 22 times 7 centimeters square. So we can get the area of the circle is 154 centimeter square. We can try to use the other formula and we get the same result. Next, before we end this video, I will give you one case about the circle area in daily life. The question is, a circular pole has a radius of 49 meters. Around the pole's edge made a circular road 7 meters wide. If the cost of building a road per 1 meter square is 15,000 rupiah, calculate the total cost of building the road. The illustration of this case is like this picture. The solution is, first we must find the area of the circular pole because the radius of the pole is known in the question, so we can use this formula. Substitution P equals 22/7 and R equals to 49, so we can get like this. So we can find the area of pole equals 22/7 times 2,401 equal to 343 meters square. After we find the area of the circular pole, next we find the area of the pole and the root. The area of pole and root equals P times R square equals 22/7 times 56 square. 56 we get from 49 plus 7. So we can get the area of pole and root equal to 448. From the area of the pole and the area of the pole and root, we can find the area of the root. The area of the root is the area of pole and root minus the area of the pole is equals to 448 minus 343 equals 105 meters square. So the total cost to build the root is an area of the root times 15,000 rupiah. So total cost to build the root equals 105 times 15,000 rupiah equals 1,575,000 rupiah. Okay, that's all material from me. I hope you can understand about the circle now. Thank you for your attention. See you on the next video. Bye-bye.